This video is for the last page of Unit 7 review, 5A, 5B, 5C, and 5D. These involve application problems of right triangle trig. So in each of these cases, we're going to go ahead and read the word problem and then take a look at our diagram and see what we can do. So a flagpole casts a 42-foot shadow. So I have a flagpole and it casts a 42-foot shadow. If the angle of elevation of the sun, so the angle from the ground up to the sun, is 57.4 degrees, as shown in the diagram, what is the height of the flagpole? So we are trying to figure out this height right there of the flagpole. So since I'm given a right triangle, I'm going to go ahead and start off like I always do by labeling my hypotenuse, which is this side, labeling the adjacent side, which is the side that makes up the angle. So that's the adjacent side, and that leaves me with the opposite. So if I'm trying to set up a trig ratio to help me find this missing side, I'm given the opposite side and the adjacent side. That is in fact going to be the tangent ratio of some angle. So plugging in my known information gives us tangent of 57.4 degrees is equal to x over 42. Much like our earlier problems, we put this over 1, cross multiply to give us our answer for x. X is equal to 42 times the tangent of 47.4. X is isolated here, so I can simply plug this into my calculator. X is equal to 65.7 feet. Okay, for 5B, a 100-foot rescue ladder, so the ladder is 100 feet, is placed on the window ledge of a third-story building window that is 45 feet off the ground, so 45 feet off the ground. What is the angle of elevation? So I'm trying to figure out the angle of elevation from the base of the ladder / ground to the window. Okay, well, in this case, if I look at my angle in question and label my side lengths, I have the hypotenuse, I have the adjacent along the bottom, and we have the opposite side. Opposite side. Well, if I'm wondering what trig function deals with the opposite side and the hypotenuse, that is in fact going to be the sine of some angle. Now, in this case, I'm actually trying to find an angle measure. So I know then that angle x is equal to the inverse sine of the opposite over the hypotenuse. So I can substitute in my known values. Opposite is 45. Hypotenuse is 100. Inverse sine will give me x degrees. So x degrees are equal to 26.7 degrees, finding out my angle of elevation. Okay, next question. Nursery plants a new tree, and attaches a guy wire, so like a support wire, to help support the tree while the roots take hold. An 8-foot wire, so the wire is 8 feet, is attached to the tree and to a stake on the ground. From the stake, the angle of elevation from ground to the connector place is 42 degrees. How far from the base of the tree is the stake? Okay, so we're trying to figure out this unknown distance from the stake to the base of the tree. So let's go ahead and once again, here's our angle measure of 42 degrees. Let's go ahead and label our side lengths. Hypotenuse, adjacent, and opposite is the height of the tree. In this particular case, I'm given the adjacent and the hypotenuse, trig function being cosine of theta. So substituting in our known information, the cosine of 42 degrees is going to be equal to x over 8. Once again, I'm put this over 1, cross multiply to figure out my value. X 8 times the cosine of 42 degrees. X is already by itself. X times 1 is x. So therefore, I can plug this into my calculator, giving me 5.95 feet. Last problem. This is a application problem that's a little bit more advanced. This actually came from a pre-calculus textbook, but it deals with the same type of problem, same type of concept. So from a point on the ground 500 feet away to the base of a building, an observer takes two angle measurements. One is a 24-degree measurement to the top of my building, and then another 27-degree measurement to the top of a flagpole that's on top of the building. The question is, what is the length of this flagpole right here? Now, you obviously do not have access to the roof to go up and just measure it, so we just simply have to work with the two measurements and the distances we are given. So from a very basic standpoint, if I want to go ahead and solve this problem, if I could find the length from the ground to the top of the flagpole, which I denoted as distance K, if I took the flagpole, could be found by taking that distance K and subtracting the distance of H, where H is in fact just the height of the building. Think about it. If I told you the distance from the ground to the top of the flagpole was 110, and I told you the distance from the ground to the top of the building was 100, you would do 110 minus 100, which would give you a distance of 10. Well, it's not that easy. We're going to have to go ahead and set it up. I'm going to go ahead and redraw the two triangles that are here. We see that we have 27 degrees is my bigger triangle, and 24 degrees is my smaller triangle. Both of the distances here are 500, as the measurements are taken from the same marking. So I'm going to go ahead and label these triangles according to these two reference angles. We have our hypotenuse. We have the adjacent side of 500 in both. And we have the opposite side for K and opposite side for H. Okay, well, in order to figure out the distance of K, we're given the opposite and the adjacent. This is the tangent ratio. Substituting in our known values, we have the tangent of 27 degrees is equal to the opposite side of K, cross multiply, K is 500 is the tangent of 27 degrees, which gives us a value approximately of K is equal to 254.8. 254.8 feet. By the same token, we can go ahead and set up a trig ratio for H. We are given the opposite and the adjacent, so once again, we are going to do the tangent ratio. The tangent is equal to 500 adjacent side. We have this time we have 24 degrees as our angle measurement. Putting this over 1, we're going to cross multiply again, giving us H is equal to 500 times the tangent of 27 degrees, giving us a value of H is equal to 222.6, 222.6 feet. Now, I wasn't asking for the two independent values. I actually want to go ahead and figure out what the values are when I subtract them. So I'm simply going to take the value of K, 254.8, and subtract it from 222.6. So again, I'm taking the K distance from the ground to the top of the flagpole and subtracting from the ground to the top of the building. And that gives us a value of approximately 32.2 feet tall for the height of my flagpole right there. Okay, so this problem basically was two trig problems in one, and we had to do something with both of our results versus these earlier problems where we're just setting up a trig ratio or inverse trig ratio and getting an answer. Here we went and one step further and actually had to do something with the answers. And in this case, in order to find the height of the flagpole, we subtracted the two values. Expect 2 to 3 application problems on the test. Great.